All right, in this section we're going to look at rational exponents. Rational meaning the exponents are rational numbers or fraction exponents. So we define a fraction exponent in the following way. A raised to the m over n power is the nth root of a to the m, or the nth root of a all raised to the m power. The idea here is that the denominator of the exponent corresponds to the index of the radical, and the numerator of the exponent is then what you're raising that as a power, like what power you're raising that to. So we're going to get a little practice evaluating. We're starting off with some numerical examples that can be with convenient numbers that we can do without a calculator. 8 raised to the 2/3 power. More often than not, when I rewrite this, I'll write it as the radical first, which is then raised to the power. So I've got the cube root of 8 squared. This is convenient because 8 is a perfect cube. The cube root of 8 is 2, and then I'm going to square that. So we get 4. And on your calculator, you can confirm this. So if I take 8 and raise it to the 2/3 power, you'll see it gives me 4. Now, depending on the operating system that's on your calculator, if you have the older one, you'll have to use parentheses for the exponent. So that would look like, so when you hit the up caret key to get an exponent, it just writes it as an up caret, and then you've got to open up parentheses, 2 divided by 3, and that'll give you 4. Without the parentheses, it'll give you 8 squared, and then divide the whole thing by 3. And that's obviously not what we want. Uh, 16 to the 3/4 power. Well, that's the 4th root of 16 raised to the 3rd power. The 4th root of 16 is 2, and 2 cubed is 8. Nine to the negative 1/2 power. I'm going to take care of that negative sign first so that I know this means 1 over 9 to the 1/2 power. So this is 1 over the square root of 9, and that gives us 1/3. 9 to the 3/2 power. That's the square root of 9, all cubed. The square root of 9 is 3, and 3 cubed is 27. Sometimes we can use this radical definition, the converting from an exponential form to a radical form to help us simplify. So here they've given us an expression, they say simplify. They've given it to us only, in exponential form. I'm probably going to write my final answer in exponential form, and there's more than one way we can get to this. So I would probably, working through this, just leave it in exponential form, unless it looks like it might be convenient to put it in a radical form. But I'm going to take this, I've got a product I'm raising to the 1/3 power, so I'm going to distribute that power over the product. Now, at this point, I'm going to find it convenient just to write this first part as a radical, because that's how I want to think about it. 8 to the 1/3 is the cube root of 8. That'll help me simplify that part. The rest of it, though, I'm going to keep in exponential form for now. If I'm raising a power to a power, I can multiply those exponents. So I get a to the 2/3, b to the 4/3. And then the cube root of 8 is 2. So 2a to the 2/3, b to the 4/3. And there it is, the simplified exponential form. Next we have x to the 3/4 times x to the 4/5. And There's not a whole lot to do here. We're going to, we're multiplying, which means we can add these exponents. So, just going to do that addition here. We're going to get a common denominator, which will end up being 20. And then we have 15 plus 16, so that's 31 over 20. So here we get x raised to the 31 over 20 power. And I'm leaving it in exponential form. When a problem is given as an exponential expression, it's conventional to give your answer in the same way. A lot of the times instructions will specify to give the answer in exponential form, or they might say convert it to radical form. If there are no instructions given, I usually default to whatever form was used in giving the problem, unless there's maybe a reason that it's particularly convenient to switch from exponential to radical form. All right, one more. It looks like there's a lot going on in this example. I've got negative exponents, I've fraction exponents, I've got a fraction inside being raised to a power. So I think we can kind of take our pick on what to attack first. The first thing I'm going to do is deal with these negative exponents. And I'm going to do that just by shuffling. I know that 4 to the negative 9/2. I can write that in the denominator as a positive 9/2 power, and then the x to the negative 1/3, I can write that in the numerator to the positive 1/3 power. So up top I've got x to the 2/3 times x to the 1/3 over 2 to the 3/2 times 4 to the 9/2, and this is all raised to the 2/3 power. The top here is going to simplify kind of nicely because we're going to add those exponents, and 2/3 plus 1/3 is 1, which means up top we've got just x to the first. Now on the bottom, I'm going to do a little bit of work to simplify this part first. So I've got my 2 to the 3/2. 4 is 2 squared, and that's the 9/2. I can raise a power to a power by multiplying, so that ends up becoming a factor of 2 to the 9th. And the 9th is, I'm just going to go ahead and write that as 18/2 because I'm going to add those exponents. So that is all to the 2/3 power. Adding those exponents, we're going to get 2 to the 21/2. And this again is still all to the 2/3 power. Okay, now I'm going to distribute this exponent. Up top, I've got x to the 2/3. On the bottom, I've got 2 to the 21/2 all raised to the 2/3 power. And we can multiply those exponents. So I think this is going to simplify kind of nicely, or at least look a little nicer than it does now. Multiplying those exponents, 21 over 2 times 2/3. The 2's cancel, 3 goes into 21 7 times, so that's 2 to the 7th. X to the 2/3 over 2 to the 7th power, or 2 to the 7th power is 128. And there we go. That is, I think, objectively simpler expression to work with than the one we started with. So, mission accomplished.